Maybe we can have just a few minutes just to see what happened if other people join in. Okay, good afternoon, good evening, I guess. So this is our first session for the official meetups for this year. So what these are going to be well, basically it's our, let's say, we want students to understand what's happening at the university, and we want to expose them to really cool tech and hopefully ignite that spark that will get them to start doing things on their own and explore and come up with even better, bigger ideas. So today we're dedicating this to computer vision, and there's a number of reasons for that, of course. Well, first of all, we have a number of things happening in computer vision at the moment. We have a number of projects. It's a really big thing in the market, and especially with what's happening with COVID, post-COVID, world is changing. And that also means that we need to understand how we can start leveraging cognitive computing a bit more. 3, 4, 5 years ago, maybe, we thought that cognitive was going to change everything. Well, that change did not really happen, but now because of COVID, the world has changed, which also means that we have an opportunity for a complete cultural shift. And that is what cognitive computing is really about. So we're just waiting a moment because our main guest is just on her joining in. Okay, do we have any person in who is doing data science at the moment?
Don't be shy, guys. You guys can turn on your camera so we can see your faces.
The whole idea here is to try and get you guys to join in. We have a number of projects which are happening, including a number of internships which will start next trimester around a few of the projects. Oh, hi Linuha, how are you? You are on mute.
Hello. Hi. How are you, everyone? Nice to meet you.
Okay. All right. I guess we have the guest, so we can probably start. So do you want to tap the record button, Doi?
Yep.
I guess maybe we can also introduce ourselves, since this might be the very first, one of the first times. Hello, I'm Alessio. I am a lecturer at Deakin University, and I am also the director of innovation, which means a lot and nothing all at the same time. It just means that I am, I can do a lot of things. And among those is also organize these events, which I hope they will help you guys to, I don't know, start working on really cool techs. So not just talk about artificial intelligence, but actually put it into practice. Zoe, you wanna?
Yeah, hi everyone. My name is Thuy Nguyen. I'm sure you have seen my emails and Teams messages everywhere. I'm the one always messaging you about these opportunities. I actually work with Alessio, and we work together to put on these activities for you. Really the aim is to give you exposure to industry outside of your curriculum and units, because we try to integrate in what industry expects from you when you enter into the job force. And for those who are really keen to kind of do their own thing, we want to kind of support you to innovate, either with ideating your own ideas, or thinking through like maybe what you want to do with your degree when it comes to, I guess, maybe starting up something on your own. So that's what I do, and support Alessio in doing that.
Yes. Okay, cool. So next one, I would like to introduce my very dear friend Linhua. So Linhua is We have known each other for a very long time now. We used to work at IBM together. We have worked on a number of projects together. Yeah, well, let's say that when we used to work together, and this is probably something that you may want to learn, is about collaborate and complement the skills. We can say that maybe Linhua is the brain and I am the arm, as in I am a developer while Linhua is an incredibly good data science person. So Linhua, leave the scene to you.
Okay, so thanks for your very nice introduction to me. Hello everyone, I'm Linhua. So for now I'm in Trobe University, and lecturer at computer science department. My research background is mainly focused on the machine learning on healthcare area. Before I joined Trobe, yes, I was in IBM research for almost 3 years. So I worked with IBM for some anyway patents projects, and I think much fun there. But anyway, we jumped from IBM. We both joined universities, even though different universities, but still we have been working together with each other. And I think, yeah, we can explore more opportunities also with you. Yeah, nice to meet everyone. Yeah, great. Thank you.
Okay. So Linhua, so here today we are, I guess, mainly talking about computer vision. We also have another guest. His name is Mohammed Reda, who is a lecturer at Deakin University, and he has recently been running an actual hackathon in computer vision. So we will give him some space to also steal the scene and talk about how the hackathon went and how the students responded. So Linhua, I guess this is more of a chat. So would you like to explain maybe your career path, or how did you develop into a professional who worked in the AI industry in both academia, but also in the actual hands-on industry where we actually have clients and we actually have targets and we have to make things?
Okay, yeah, this is a big question. Actually, I did my PhD in University of Technology Sydney, and the center I was in is quantum computing and intelligent system. Yeah, I think QCIS. Yeah. So from there, I think before I had no much idea about machine learning or AI something, but from my PhD experience, I started to just to be more, I think, more and more interested in this area, because I can say there's so big potential from the technology. We can do, yeah, so many interesting stuff. Even some research work can be can bring more benefits to the whole society or community. But actually during my PhD, I was just focused on the research papers, not so much about the practical or real world projects. But after I joined IBM, I just, yeah, I met with some clients, also some from different industries people. I found even like I think I was working with an essay on the patent about the story making with from the text to the video. So like that was an idea. Like we after a chat with the news from the one friend from the which company, I forgot the name, but anyway, I think they had some problems, but they don't know how to solve that. And we have the technical skills, and we have some research background. So I think it's very complementary. We can get some good ideas to really solve some problem. I think this is kind of more and more motivations for us to work on this. And then after I joined Natural, I visited Harvard Medical School in 2018. And I worked with some partners in Harvard for this autism screening. And even until now, we have been working on this area because I think this really good opportunity for us to make use of AI technology to do something for the whole society, for the whole community, for autism children. I think, yeah, big potential. And most important is that you really, it's like responsibility or your interest or your motivation, or maybe you can get some fun from there, from this kind of achievements. So yeah, this is how I am working on this kind of research area, and also I'm keep this passion in here. Yeah.
Okay, so I think the question then would be, would you like to talk about the actual project that you're running at the moment? I think we can also show a demo later. Where did it start, and where do you think it's going?
Yeah, I can show a demo. yes. This one is we just made a demo, so maybe I can share with you the. Okay, let me share with you something. Yeah, so this is the one. Maybe you also can try this one, asdai.today. Yeah, so you can access this page. So this demo is about this ASD face. So we're trying to use AI technology to detect the autism from the facial images. So this is the one, and the demo here is that we only need the face image, for example, and we can upload an image here, and we can do the prediction, and it will give you outcome. Maybe this one is lower probability of having ASD. So why we had this research? Because we know autism is quite very big number, and more children they got autism in different countries, even I think mostly in Western countries, including Australia. And recently, many clinical studies have shown that a broad ASD phenotype expressed in the facial morphology. So facial features. So this is why we can use the facial features to do this detection for the ASD. So this is why we have this research, and we really can achieve more than 88% of the accuracy for now. So I think it's quite a big achievement, because we use only single source data, just the facial image, and we can achieve more than 88% accuracy. And if we try another one, yeah, so this is another image, and we can do another prediction, and the result, okay, this child may have a higher probability of having ASD. Yeah, so this is very initial work on this ASD with AI, and we are working also on another different data type, including the eye tracking, or even some other time series data or background information. So maybe I believe with multi-source data sets, we can achieve much higher accuracy. Yeah. So this is the current work we are doing, and hopefully we can just keep working on this for even great achievement, and then hopefully this can be used for more children, yeah, with autism or ASD, yeah, autism. Thank you, everyone. Yeah. Okay, let's stop sharing.
So I think this is a very important part, especially because of COVID. We're basically redesigning how we deal with health. More and more, we're going to see applications and let's say self-diagnose ourselves. Like we don't need to go to the doctor for a number of reasons. First of all, why drive to the doctor when you can do it at home? And the second part is also, try to decrease the amount of pressure that we put onto the system. And I believe that COVID really showed that our health system can't really deal with, with this crisis very well. So does anyone have any questions around this project? Because our idea for the next trimester was to actually have some students perhaps to contribute and help and understand a little bit better how this project works, and maybe, contribute to the training, or, have some collaborate. Maybe we'll take you somewhere, maybe we'll, who knows? Or if you're too shy, we can talk about this later.
Just ask maybe a technical question to,
Sure.
Just a technical one. How did you collect and label the data set? And is there any privacy issue with this data set?
Okay, you mean for the ASD data set?
Yeah.
Oh, I understand. So this one is the public one we can use. Yeah, but I understand the normally it's quite sensitive if we are using the facial images. Yeah, but this the public one we available for the researchers to do the testing. So we are, yeah, if we still can collect some more facial images, but we were not show the details in the paper. Yeah, just for the performance testing, not for the for other purpose. Yeah. Thank you. This good question. Yeah. Yes.
I think this,
very sensitive.
This paper was presented at AGCI, I remember.
No?
AGCA? Yeah.
Yeah.
But
it's an interesting read. So I guess, yes, so this is where we want to try and go. I mean, this is there's actually a question. Do you think it will be possible to identify autism with some sort of game, like some jobs testing interviews behavior with small games? You know how some interviews.
Yeah, I think this could be the behavioral detection. So we depends on the data. I think it's possible because our next step is trying to connect more data from different source, like even behavior. Like normally behavior data can be recorded in a radio, so we can detect. So this I think is very relevant to the computer vision. So we can detect the behavior in that radio, and to say the to do this ASD screening. This could be another I think quite potential work for us to focus on. Yeah.
I want to ask the opposite then, because we all, and I think this is a question of 2021 or 2020. So if you can find out if you have ASD from a picture, what does that mean if you are doing a job interview and the person actually finds out, potentially the system detects that you have ASD? I guess this goes into the AI ethics.
This could be really good question. Yeah, good. Nice. Yeah, I see. Okay. I cannot, for now, I don't have a very clear answer for this, but I believe that could be a very interesting area to explore, and we can, and it could be awesome if we can really make it. Yeah,
I think this was a discussion that came out last year when a lot of companies actually dropped the AI data set. I think IBM was one of the first that they basically abandoned the face recognition because it was too biased and people were using it for the wrong reasons.
Okay.
So there was huge discussions, and I think in the future there could be even just a whole bunch of research, even just to answer this question. So
I see. Okay, this is a good question, and also can inspire us to maybe do further work.
Yeah.
The game would be more popular anyway for young people, even for children. Yeah. Mm.
yes, and I think there was a just to finish off. I think last year we, in response to the game, we actually met a company which was AI on the Spectrum, I think it was, which is actually a Melbourne company. They came first in the Founders Festival. So it's a startup company. So it was made by students, really. And they were doing image detection, pose detection for autism, more based on the actual behavior. So yeah, those things exist. And it was done by students. And they came first in the competition. So good on them.
So there are other technical questions posted on this chat box. Kalum is asking if he can get access to the paper describing this project, or at least describing the algorithm or the tool you have proposed to solve this problem. And he's also asking another technical question, which is about, is the autism dataset imbalanced, right? This is a binary classification problem, right? And is it balanced or imbalanced? And if so, how do you do it? Yeah.
Yeah, for this one, the data set is normal, is roughly balanced, but we also did some research for that time series data set, but imbalanced, and that is not a very I think this imbalanced or balanced one is already solved. I think mostly already solved with AI technology, AI algorithms. So this could, you can check some, maybe I will share with you some papers. So that already solved. So this is why in our demo, we just try to focus on that, because only get the data and we didn't test for the imbalanced or balanced data set. Yeah, in this one.
And
but I believe balanced or imbalanced, this problem already been solved somehow. Yeah. Mm.
Yeah, and there are, just for Column, because I know that Column is enrolled in the SIT 799, our deep learning unit. So yeah, there is definitely a problem when you have to deal with, imbalanced data sets. Often, in that case, it's a binary classification problem. Using the accuracy may not be the best metric to assess how good is your classification algorithm, right? So you need maybe to find other alternatives. And sometimes also, if you look at a library like liblinear or libsvm, they have a technical way to deal with the case where you have an imbalanced data set through this weighting term, right? They use that weighting term in order to adjust the parameters of different classes. So I just have a look at this column.
Yeah, there are different strategies to deal with the imbalanced data set. Even like what you mentioned just now with and also they have some different attention for that kind of data set, and when design the whole algorithm and model, so there is attention, normally the attention based framework or model can be maybe suitable for the imbalanced data set. So there are different methodologies on this, but depends on the details of the imbalanced data, and so may have different solutions.
Anand is also asking, could you tell us more about the facial features used for training the model and how the model performed? I mean, did you use, maybe he's talking about using a CNN, or what kind of features are you extracting from images?
Yeah, so actually from the image, we're trying to just get so like in the facial morphology, you can see the phenotype can be expressed in that. So ASD, because they're rendering to the ASD medical knowledge is their very broad ASD phenotype can be expressed in the facial morphology. So this why we can just get that information for the detection. Yeah.
And maybe what part of the facial morphology indicates more that this person has autism? Is it the mouth? Is it the eyes? Is it?
It's not only single. It's the overall. So it's quite complicated to clearly explain that. But I can share you with the detail afterwards. So it's more. It's not just the mouth. It's the overall something, some features. Yeah.
I think we can. So what we can do, we can actually share the paper later if you have it. I mean, you should have the paper. So we can share the link to the paper. Link. So you said the data set is public, right?
The data set is public. Yeah, but then there's no link. I think my research partner just keeps the data set. So I don't know which link, but I can ask.
Yeah, we can find it. Yeah. Okay. Okay. So I guess this one is was a discussion around the ASD AI. So you can actually go and test it. So it's the ASDAI.today. So it's available publicly. It's running on my machine, so please don't make it explode. Don't send it too many images. But it should be fine. But yeah, so this is one way that I personally really like, how we make use of AI to make a better world. And there's a lot more ways, and I'm sure that maybe some of you will come up with even, I'm not saying even better, but with great ideas in the future. So does anyone have any questions from an actual career perspective or anything around this area? The main thing is just because Linhua actually came from an industry, so. Okay.
I'm kind of sorry.
Oh, Katrina, yes.
Hang on, I'll try not to be so rude. Oh, can you see me?
Yes.
Yeah, I'm sort of curious in industry. What's the kind of employment like, or where do people get jobs, or do you have to go create your own? Like, do you go, I have a fantastic idea, I'll find investors? I don't know. How does it all work? What's the landscape look like? Any idea?
Okay, so I think we can both answer on that side because I'm actually dealing with quite a large number of those. So it really depends where you want to be. If you want to, find a job in a, so if you're a data scientist and you're a pure data scientist, then I think there are plenty of jobs out there in this field, but that is for pure data scientists who have very good understanding of how to apply and how to make changes to the existing frameworks. But if you're looking more as a software engineer, then it's a completely different story. That's where you maybe want to try and actually work for startups. I think there was an actual, there was a link from Civic Labs. So Civic Labs is this huge incubator, which is government-based in Melbourne. And they basically have a lot of information about how to go and work for a startup. So generally, startups really look good for software engineers who are more towards the putting together things, making things happen. And then there's the last part, which is the, oh my God. Oh yeah, maybe go and start on your own. So we actually have a number of those happening, a launchpad at the moment. I think Manas is going to show us one of them. No, we actually two. So one of them is, for example, the creation of virtual avatars and really high resolution avatars, which we hope to use for the fashion industry. And basically, that was a startup. They just wanted to do this and they were looking for technical competence. So they came to us. And then we have another version, which is using computer vision for health and safety in the workplace. And we're going to show a video about that later. And then again, we basically created a small prototype, which we are finishing next week. And the idea is to go to investors and basically ask them for more money to make it happen. And so there is no real, there's no exact answer to any of those. The opportunities are there. Have to explore the world a little bit more. Hope that answers.
Yeah, no, I get the gist. That's great. Thanks.
Yeah. I mean, if you're looking for something like that, we actually know a few companies who are looking for software engineers in that specific area. Okay, we have one from Ognen. Are there any part-time jobs like 2 days per week for aspiring data scientists? If yes, how to find them? So I think this is a question that people normally ask, how to become a data scientist. And I think this is something that we have been discussing in the last few months, which is, how do you call yourself a data scientist? What makes you a data scientist? So I've met a lot of people. For the guys who don't know, I run the Launchpad at Deakin. So I interview maybe 200 to 250 students every year, probably more. And a lot of people who claim to be data scientists have no idea what they're actually doing. So I think first of all is try to build a profile, try to become good at something. You're a data scientist. What are you good at? Machine learning? Are you good at AI? Are you good at computer vision? Data science is very broad. But we can talk about this later. We actually had a number of positions, even paid positions at Deakin. So please feel free to reach out to me later. So before I continue answering, I wanted to have Mohammed to present his work, maybe.
In fact, I go by Reda. That's the name.
Yeah, I know. It's just,
but anyway,
that's what I go
yeah.
by. I mean, that's not what I go by.
So most of you,
Reda.
I think most of you here, they know me and I know them. Some of the students here are already enrolled in the Master of AI or Data Science, and they are also enrolled in the Deep Learning unit, which I'm teaching. I just wanted again to talk about this competition that we are organizing this trimester, which is this Deakin Simpsons Challenge. It's a computer vision challenge. Let me just share my screen. It's really bizarre, but anyway, yeah. So can you see it, guys?
Yes.
Yeah. So again, I mean, most of you, they are already aware of this challenge that we are organizing. This is what we call the Deakin Simpsons Challenge. It's a pure computer vision task. The goal of this task is to recognize basically Simpsons characters from images. This challenge is designed to provide the opportunity to work as team members, right? To collaborate with each other, to compete against each other, to enhance your learning experience by improving your AI modeling skills, your problem solving skills, and your team working skills. That's really the main goal of this challenge. So it's really that something also important to mention here is that this challenge is designed with the same norms as any challenge organized in the top tier AI conference, with a validation leaderboard plus a testing leaderboard. So I think most of you, you have already participated. You have already made a submission to the leaderboard. All you have to do, in fact, to participate is to register on this Codala platform, and then build your own model and submit your own model. Okay, you can work in a team or you can work individually. So the main question that you may ask is, why should you participate to this challenge, right? What's the benefit of participating? So first of all, we will be giving at the end of this challenge an official award, school award, that will be given to you, right? And basically it will provide to you an invaluable recognition for your achievement in this task. So an award is always critical when you apply for a job or a PhD position or scholarship, right? So it's really, I believe that it's really the perfect place to learn best practices in AI, artificial intelligence, to accurate feedback on your work, because you can submit your model on the leaderboard and get instant feedback, right? And you see how it performs compared to other competitors. And also it's a really good way to augment your skills and improve your skills, right? It's really, for me, you know, a good channel for problem solving and brainstorming. It can also be seen as the opportunity to push boundaries, right? And encourage creativity. And again, the experience you will get is invaluable. Because it will help you in preparing you to understand what goes into finding a feasible solution to a big data problem. So you can go online. We are still running the competition. It's not finished yet. You can go on the Codalab link or the official GitHub page of the competition, and there are all the instructions you need in order to participate and build your model. So please note that we are already providing a template that you can use straight to make your first submission, build your first model. And the challenge is really about, you know, improving the initial model given to you. You can go to the leaderboard. You can see that we already do have a number of participants. So some students are participating by themselves. Some other students are participating in a team. Right, and you can see the teams here. For now, I think we have more than 30 participants, maybe 34 or 35 participants. I'm really impressed by the accuracy that some of you have achieved. I myself, I don't think I can reach that high value for accuracy. So the total number of submissions so far is it's 329 submissions that have been, you know, submitted to the platform for a total number of 26 teams or unique participants. So again, please feel free to try it. Just go online. I will post this link again on the chat box. Just go online and try it by yourself.
Okay, let's have a look. There are more questions which we can try to ask. I try to answer. That would make sense. So would you say that field for AI and machine learning is mainly for people with a specialized master's or PhD, or is it more approachable for a broader computer science undergrad? Let's have a look. So I think this is a question that I would like to maybe have. I think everybody will have a different answer for this. Is Manas, are you online? So Manas is actually presenting some of the work later. Just checking if he's on, if he's here, because he can probably give a better thing about this. So specialized master's or PhD, better than computer science. I would say the computer science from, this will be my perspective from a software engineer, pure software engineer. It's mainly about what you're trying to do, really. So I think, and with what is really important is the maths behind it. I have seen a lot of people who treat machine learning or deep learning as a black box, as this magic black box. And that's where you can tell the difference between the really good scientist and the not so good scientist. So I really wanted to try and have Manas to talk about this, because he's going through a lot of this stuff at the moment. So maybe I'll get back to this question, but maybe Rita or Linhua, would you like to contribute? What makes a good person in machine learning or AI?
Look, my opinion is it doesn't really depend whether you have a PhD, master, or even a bachelor degree, right? If you are good, you are good. I've worked with some undergrad students, very good undergrad students, and I've seen some undergrad students publishing in top journals or even top conferences, right? And so for me, an undergrad student can work by himself to improve his AI skills, his machine learning or deep learning skills, right? I always tend to say to students, don't count on the unit, on the university to teach you everything you need. Rather, you need to go by yourself. There are a lot of tutorials online on YouTube, on Coursera, on many other platforms. Just go online, try to do it by yourself, and you can gain a lot of skills in terms of machine learning and deep learning, right? I mean, yeah. So it's not dependent on the degree.
Inhua, on your side, any comments?
Just the one word, you need to be creative. Yeah.
Yeah, I think that's very important. So we think that machine learning and or AI are these tools that we use to make magic happen. But actually in the last month or so, so me and Manas, one of my students, we've been working on this product for healthcare and workplace safety. And we really had to jump a lot of through a lot of hoops to try and achieve the target, but also making sure that our machine did not explode. Because at the end of the day, we're making a product. And there are many ways to achieve the same outcome. And throwing an A-bomb to kill an ant is not a good way, which is sometimes what a lot of people do. So for example, for us, we are trying to minimize the resources that we need to run a lot of different models. So we had to come up really with some creative ways of making models run in parallel without the need for huge resources. Yeah, and so basically we managed to go from, I think, 5 frames per second to basically achieve the same outcome with 20 frames per second. And that was just about doing things like, I don't know, analyze one frame with a set of the models and another frame with another set of the model. A lot of creativity there, a lot of creativity. So that's more from an engineer point of view. Manas is having some problems with the Wi-Fi. I hope he can join soon because I would like him to talk about this, not me. Yes. Okay, so I think if there's any other question, there are many data science jobs advertised, but limited AI related. Any tips on how could we explore and apply for AI jobs or internships? That's a good question. There are many data science jobs. So it would, in my opinion, it depends on what you mean by data science jobs. There's this kind of joke where we say that if you know Tableau, you're a data scientist. We can say that that could be your first step, like understanding the data. But there's way too many people who believe that if they can use Excel, if they can do an HLOOKUP on Excel, it makes them a data scientist. So I think you need to first understand what kind of data scientist you are, which is why you need to choose one particular topic. You can't be a data scientist in everything, because otherwise you won't be able to sell yourself. Manas, thank you. So I have a
Hi.
question for you. So
Extremely sorry for joining late. I have some problems with the Wi-Fi in here.
okay.
Yeah.
So just a small intro. So Manas is this really great guy that he came to me last year to do a major thesis. And then for some reason he couldn't do it. And then he reappeared late last year. But basically he spent a whole year by himself learning about computer vision. So Manas, the question is,
Yeah.
I think this is a perfect question for you. Where is it? Would you say the field of AI and machine learning is mainly for people with a specialized master or PhD, or is it more approachable for a broader computer science undergrad?
I would say the AI field is for the person who is trying to solve a problem. So his whole purpose should be solving a problem rather than the field he's in. So if he's trying to achieve one problem and it needs an AI, I think he can learn AI pretty much easily without a degree, and for that problem. So it's more about how quick, how efficient he want to uh, solve the problem.
And I think I wanted to bring up, so we asked this to Linhua, and she basically just said that what's important is creativity.
Yeah.
And I think I just mentioned that on our latest work, we actually really had to invent a lot of things to try and make things happen.
Yes. So me and Alicia are working on a project called AI Health and Safety. So I'm just going to share my screen and present a little of the project we're working right now.
Oh, you actually made a presentation. Oh, wow.
So I think, yeah, so our project is basically it's around health and safety within a workplace. So we are using computer vision to solve this problem. Not solve, but to help or to minimize this risk of accidents in work locations. So I'll just go through the methodologies that we use in a technical way to solve this problem. So yeah. So our AI system basically comprises of three main components, which is the object detection. So we are using object detection to detect hard hats, the construction hat, the construction vests, and the intrusion detection is basically an imaginary zone or a geofence which is drawn on the video. And if a person steps onto this intrusion or restricted zone, it would notify that it's a violation occurred. And we are also using a pose estimation algorithms to recognize the pose of a person. And we are trying to build a classifier on top of a pose, which classifies if a person is falling or if a person is running in a workplace, which is not usual at work locations. So yeah. And then there is another system which basically triggers the events, uploads it, and gives us notifications when the violations has occurred. Yeah. So the main methodology is we are solely based on supervised learning. Supervised learning is nothing but we have the data and we are expecting a certain result. Suppose we have a picture of a person who is not wearing a vest. We have a picture of a person who is wearing a vest, and we have labeled them. Now we are using this data to train our model. So this methodology is known as supervised learning. There are other methodologies as well, unsupervised learning and stuff. And the other thing is transfer learning. So transfer learning is nothing but we build on top of a pre-trained model. So we are using a state-of-the-art models which are available online, which are published by bigger organizations like Facebook, Google, Microsoft, and we are trying to build on top of these models. And we are also using strategies like data augmentation. So this data augmentation plays a vital role when we have very less data to work with. So suppose we have 10 images of dogs and we are trying to classify dogs. This data augmentation approach, there are certain strategies in data augmentation. One basic strategy would be flipping the image horizontally so that it would just double your data set. So 10 images would become 20, and now you have 20 images to work with. So that's one small aspect of data augmentation. And the object tracking. So the object tracking is really important when it comes to CCTV footages or tracking people, because we see many people in the footage, but the system needs to understand and label each and every single person so that it would keep a track of it during the entire duration of a person within the frame. So we are using a deep sort algorithm in order to do that. So I'll go through the structure, go through the flow of building a TensorFlow object detection model. So for this project, we are using a TensorFlow object detection API, which is by TensorFlow itself, and it's a version 2 API. So this API works in two ways. So on the one hand, it's purely collecting data. So that's completely done by us. And the other way is, in the second side is, it gives us pre-trained models, which are state-of-the-art models. And we have to build these pre-trained models using our data. So initially, we collect a lot of images from internet. We try downloading videos from YouTube, try segmenting those videos, get frames from the videos, label them manually. Suppose labeling, there are certain tools to label these videos. We use image labeling tools to draw bounding boxes, get the XML files. So they're stored in the file format of XMLs, and then convert these XML files to TF records. These kind of TensorFlow records are nothing but like a database, which is given to the training file for TensorFlow object detection API. So on the other hand, we basically select one model from the TensorFlow object detection zoo. Selection of model is really a tricky part, because that's where your hardware configuration comes into the picture. We should always have a balance between the hardware we have and the accuracy or the level of the frame rate we are trying to achieve. So we need to have a balance of all the three things when we are selecting a model. So we have selected a model which runs in real time, a near real time, close to 15 to 20 FPS, which would also give a reasonable accuracy. And once we select a model, we need to specify how are we going to train that model. Suppose, yeah, I will go more into the model training later on in the later slides. So this is just an a way of putting all things together as a diagram. So yeah. So in the object detection section, what we did is hard hat detection. We used CentiNet model, which was state-of-the-art model in the year 2019, which is trained on COCO dataset, it's a popular dataset known as Common Objects in Context. So we use this data set and we fine tune. Fine tune is something called transfer learning. I've explained it in the earlier slides. So we use methodology called transfer learning. We manually annotated 5,000 images of hard hats, just like this in the picture, and we use them for training. So our model achieves around 25 FPS. The accuracies, the accuracy number, obviously, it's not gonna really matter unless we have a data set which is a standardized data set. So it always depends, the accuracy of false positives are always depends upon the use cases. And going to the West data set, so we use the same model to classify the West as well. However, we found very few West images online. And yeah, we had to do some data augmentation in order to achieve a good accuracy. So the intrusion detection is placing geofences on the video itself. And if a person tries to, if a person steps onto the zone, it would notify us immediately. So it would keep track of people and it would notify as soon as they step onto a zone. Running detection. So currently we're working on running detection. So our running detection model would track people and label them with IDs. And once we have the IDs of each person in the frame, we can now calculate how far they're moving from one frame to another frame with suppose of 3 seconds or 5 seconds. Now we got the distance, speed they've traveled. Now we say if they're running or walking. So the training. So in the training part, it's basically trial and error, or I would say it completely depends upon the data we have, the model we have chosen, the hardware we are running on. So many aspects would come in the part of training. And to give a broad way, I would say these are the training matrices we have used in our project. So we work with some batch size of 8 to batch size of 32. It's extremely hard to use batch sizes because people think that we can just put 64 batch size or 128 batch size and run the program, but it's extremely difficult when dealing with computer vision projects. I will explain that in the future slides. So yeah, for the loss function, we have used 2 loss functions. One, L1 loss is basically a regression loss, which is used to compute the bounding boxes. And the focal loss is by Facebook. It was released in 2018. So this focal loss is an unbiased focal loss, which balance out if there is a huge class imbalance within the data sets. So in case if there are more hat images than West images, so it would balance out them and give us unbiased results. So once we train our network, we basically log all the results in the tensor board. So this is our picture of tensor board. It gives you a broad training. So this is how we basically train networks and keep a track of them. So yeah, on the left side, you see a training session. So suppose it's a file name convention. Suppose it says West detection S10, that is 10,000 steps, and B8 batch size of 8, and 0.001, that's a learning rate we use for that particular session. And now we have the color, we check the graph, we check the loss function, how the model is performing. Based on the numbers, we try different matrices and train it again, and then until we get the proper results. So we see results where the loss is converged. So I would say we shouldn't train it to a certain point that we get biased results. So we need to stop training at a certain time or certain point so that we would get optimum results. So yeah, so we have a video. So we made a small video of our results. So I would like to play this video. Just a second.
We really need to change this thumbnail.
It's you supervising, so I think it's good. I'll just play it in my browser.
Yeah, just play it.
Yeah.
And please forgive the very cheesy music. Is it gonna play?
Yes, I think. Yeah, are you guys able to watch it?
No.
No?
So I got it open on YouTube. I can just run it from mine. Yeah, so we can stop it for a moment there. Okay, thank you so much, Manas. So
Yeah.
Manas, was AI your major?
I stepped onto computer vision projects only for my major thesis. Before my major thesis, I had a long break. I had to take a long break, and I had nothing to do. So I was exploring different fields within AI. Then I saw this AI is basically like a big ocean. So you need to find a spot where you need to fit in and try to make it your own. So I selected this computer vision as my major project. Try to work on depth estimation, semantic segmentation in my thesis. So that's how I got interest on computer vision projects and started this one.
Okay, so I'll play the video, the super cheesy video. But anyway, all right. So how do I share? Am I able to share? You stop sharing so I can share mine.
Yes.
So this is a work that I guess we have done. Well, it's mostly Manas. I'm just helping him making things happen or dealing with the client, which is not such an easy thing.
Yeah, that's the important thing in the project.
Yes. Okay. You can see it, right?
Yeah.
Okay, I guess you get what we're trying to do. Yeah, so this is actually something where we we work towards an actual objective, and how we get to that objective, the journey, it's not always predefined. I think when we started this, we thought, okay, we're gonna do this in this way, we can finish this off in a weekend. That's at least that's what Manas told me the first time. But then we found all kind of problems, all sort of issues. And we just wanted to push it anyway. We wanted to try and come up with something cool rather than just copy and paste snippets of code. And that's where I think we had endless discussions about how do we run it? How do we run the models? Do we run them in parallel? Do we want to serialize them? Do we want to run TensorFlow service instead? Yeah, it was really interesting even for me, because it was about understanding how do we do not just the AI engineering, but also how to do the system engineering to facilitate the AI. So those are things that are very important, because otherwise, if you think about this, if me and Manas have our twins and they're doing the same project, but they're not thinking about optimization, the one thing that they may need to do is to have a GPU twice as big as ours, which in money, it's a lot. Running cloud services for AI, it's extremely expensive. I think $4 per hour.
Yeah,
So,
$4 to $5 per hour. Yeah.
Yeah, so imagine that times 30 days, that's around $3,000 US.
Yes.
So imagine if you have to do 2 machines. So optimizing, play around with things, it's what puts you on top of everybody else. And also I think it's been a very good learning experience for both me and Manas. So any questions around this? Is anyone interested in something like this?
I have a few questions. Like, when you build a model, how did you actually evaluate? How did you know it's working? I know I could see a bounding boxes, right? But
Yeah.
did you actually use like a, testing samples or testing set to evaluate using something like MAP, or it could be like, I think, intersection over union sort of thing?
Yes, definitely. So the intersection over union is the metrics we evaluate our models. However, this metrics is already logged while it is training. So while training, what we do is, as we give our training data set, we also give our test data set. There is this cool feature in TensorFlow Object Detection API where it trains a network until, suppose, say 1,000 steps, and then it runs an evaluation. So once it gives you an evaluation results, you can basically see your evaluation results right at 1,000 steps, and you can continue your training to until your last step, which is 10,000. So for every 1,000 step, it gives you the evaluation report, so that you don't overtrain the model. You know where exactly to stop the model, and you anyways have your evaluation results right in the dashboard. I can give you pretty good look at the evaluation. Just give me a second.
So for those guys who are interested,
yeah,
I mean, this will have to go through your supervisor or through somebody at Deakin. You can't just go by yourself. But we have fairly large machines that you guys can use to do some pretty cool stuff.
yes.
So for example, I think the training that Manas was doing on his machine, and Manas is running a 2080 RTX, is that correct?
Yes, 2080 RTX, and most of the training I've done on the Deakin servers. But yeah, not too necessary, but it's a good to have.
Yeah, I mean, if you think that if you need to spend 8 hours training versus maybe a couple of hours,
Yeah.
unfortunately you can't. If you are running a project which only lasts a month, and basically you spend 8 hours running one training and maybe it doesn't go that well.
Yes. So this is the thing I was talking about, the TensorFlow dashboard. So it has a feature to log the results. So suppose if I'm at 3,000 training step, and this is my ground truth, which is the image which I sent it to the model, and how well did it perform? Is this? I can look it on the left side, so I can just slide yeah, that's what the result I got for this particular training, and I can do that for all the other trainings that I've done. So for every single thing, I can just do it for every step. So initially it would give the bad results. I mean, it always depends upon what exactly we are selecting, how well we are training the models. And yeah, it may not even give you the right results even after training for a long time. So it
Sorry,
always depends. Yeah.
just a question. What does it mean 86% here? Is it the size or the
The 86% is the
Confidence?
is a accuracy
I think
that
the confidence, yeah.
Is
yeah
it
the confidence.
score?
So now you can say that the model is extremely bad because it's 86% giving us a wrong result.
Oh wait, why is it
Yeah,
86%
so
wrong?
it's no west and this is west. So
Oh,
I would say what happened was the model was totally trained on color images. So in this there is no west of green color, and you can barely see the west. So the model straight away classified it as no west, even though the training data has a west on it, because this is not actually the training data, this is testing data. This is manually labeled by a person. So yeah, we would even label a small amount of orange pixels like this as a west, because we know that it's a west, but the model doesn't know that accurately. But for the rest,
And
yeah.
I think for the vest, we actually did our own annotation. So
Yes, even for the helmet, for some extent, we did our own annotations just to increase the data set.
yeah, so I mean, it's always nice when you already have something done, but if
Yes.
you are trying to do something that other people haven't done, the main reason could be that there was no data available.
Yeah.
Which is the biggest problem. So for example, now we have a data set with about 1,000 vests, which potentially we should go and publish. Yes, we should.
Yeah. And this is the main, so here, if I train the model long enough, it's going to bias the results. And so I've trained this model for 12,000 steps, which is unnecessary. I wanted to test its limits. So
what is
I
a
was,
step? Is it an epoch?
yeah, it's an epoch, but especially in TensorFlow object detection, we consider everything as steps. So batch size into steps, you get epochs. Sorry, divided by batch size, 6,000 divided by the batch size, you get the
Yeah,
number.
I got it. So a step means one update.
Yeah, so one iteration is called as one step.
One update, one iteration of the gradient descent, right?
Yeah. And you would log the results like this. You would know all the step values, where exactly the model has been converged. This is more of your analytical skills to analyze where exactly you need to stop training.
So did you say you use CentiNet or something for the pre-trained model, or was it EPCentiNet something? I
On the
think there are like a
CentiNet?
faster,
Yes.
yeah, like
Yeah.
faster
So,
RTNN and others are available. Because I'm currently working on the same problem, but I'm trying to understand the few such learning. So
yes, perfect. So this API would give us some pre-trained models. We could download these papers outside as well. We could use them as we like, because they're like open source models. The faster RCNN, which is a mask RCNN, these are the famous models by Google itself. But there are other state-of-the-art models which are private models, but some contributors, TensorFlow contributors, have managed to work them using TensorFlow, and the object detection API basically added those models for us to use. So there are some models. The important thing is, how are we going to select a model? So it's on the accuracy. So you can see the model which has higher accuracy has very, very high latency. that's 268. That's nothing but 2 frames per second, which is extremely slow. And it could be extremely slow when you calculate, when you do more things on top of this model. So you need to do some visualization, displaying stuff, write, read, write, enable triggers, save data. These are all going to take a lot of computation, and you have to consider those computation times as well. So altogether, we were using CentiNet, this one for the pose estimation. We were using this one for the hat detection, hat and the vest detection. And we were using this one for human tracking. It's always the balance between the speed and the accuracy.
Also, wouldn't we consider more like if you have a similar data set that's already been trained on, for example, if you doing something with animal, maybe you would go with Coco dataset that's already been trained on Coco dataset, right?
Yes.
So that would make more sense because you don't want something that is completely out of the, let's say, domain, and you trying to sort of bring that, then it would not really work well, I guess.
Exactly. So that's where so that's the methodology of transfer learning. So so core purpose of transfer learning is to use the weights that the model has been already trained on. So we consider that the model is already good enough to do certain tasks, and it is good in. So we also consider that the model would be good enough to treat this task as equal as the task it was trained for.
And all these models are, I guess, are based on the similar approach as the YOLO algorithm.
I didn't no. So the YOLO algorithm is quite different, and it's I would say it's a. So when it comes to designing the algorithm, there is two things. One is one shot detector and the 2-shot detector. So
now, I mean, what do you predict here? What is your prediction?
So yeah, so this is hourglass. These are hourglass networks. All the CentiNet models are hourglass networks. So hourglass is a backbone for this networks, and this ResNet 50 is again different. So the ResNet 50.
No, wait. Okay, I do understand what is RedNet 50. What is this? All this mobile net stuff. So this is the convolutional part.
Exactly, the convolutional part.
I'm talking about the output, like really the classification or the identification part, the object identification part. Are they all based on the same idea as the YOLO algorithm? You look only once, or?
Yeah, so you look only once is a strategy that they've implemented. But these have their own strategies of getting you the bounding boxes. So YOLO, it's just one quick way of finding which frame you're looking, which convolution basically you're looking at. But these are all have like completely different. So this FPN is basically, FPN is also by Facebook, and FPN networks are usually they're called oh god, the abbreviation. They basically focus on one region, and then
ROI. They use
ROI. Kind of they use ROI, region of interest, and grab that region and try to find stuff on that region. And the same goes with the mark.
So when you say they focus on what region, do you mean the region of the image?
Yes. So they would consider few regions in the image that's based upon the backbone results. So the inception backbone would give you a feature network. So
they give you a feature map. Look, I do understand that this part.
So based on the feature part, they would consider few region of interest within the image, and then they segment those images and run whatever their algorithm to detect the bounding boxes. Just like YOLO using, you only look one strategy. So they have their own strategies to do once it is segmented.
I'm still not 100% understanding what you mean by segmenting, but the YOLO algorithm basically it's just a strategy. It's just an output strategy where basically they tells you what is the center of the object, what is the width and height of the bounding box. That's it.
Yeah,
And they
exactly.
scan the image only once.
Yeah,
This is why it's
exactly.
called YOLO.
So YOLO has so what YOLO does is it looks at the entire image. So it
Yes.
looks at the entire image and it would just move the bounding boxes from left to right continuously and shifting downwards.
No, that's not the YOLO algorithm. No, YOLO algorithm, it's not about this strategy of having, or trying to find an object in the image, but basically you process the image just once. That's it. You do not move, you do not try to scan the image region by region. That's not the YOLO algorithm. YOLO algorithm, you scan the image using a convolutional neural network and you make a prediction.
So what convolutional neural network does is scan using filters.
Yeah, that's
so
just
it
a
uses
mapping.
something filters. So I was literally saying that.
That's just a feature map. That's just a way of constructing features. But I'm a little bit, I still didn't get what is the output for this.
In order to understand the network architecture itself, you need to really study the paper, the paper of how this model is created. So so right now what we are talking is how to use these models in order to solve our main problem. So initially I said one thing. So if you want to be a data scientist of solving problems, you need to know how to use stuff and solve the problem. It's if we are looking forward to build a new network out of a backbone, then you're going to work on what strategies or the backbone needs to be. So how are you using those backbone features to build your strategy and get an optimum result? So it's not about achieving the score or getting a state-of-the-art accuracy on Coco dataset. It's about achieving accuracy on our own problem, which is the hat detection and the vest detection, which we are trying to do.
I think at the end of the day, I think this is what a client would ask, because it's very hard. So this is, I guess this is where you learn to deal with clients. How do you explain AI to a client?
Yeah,
because they start seeing those numbers, and really when they see those numbers, their head goes crazy, because it's like, oh, why aren't they not 100%? And it's a bit hard to make them understand what those numbers mean.
And YOLO, so for now, I think the YOLO V4 gives around 44%, 44 to 50% accuracy on Coco dataset. It always depends upon the image resolution you use and the frame rate you get and the GPU you're running on. So you need to find the balance. So what we thought was it's fairly difficult to use a YOLO algorithm. I mean, pre-trained YOLO network to basically fulfill the task of detecting hats and vests.
Yeah,
I think this is like a straightforward way.
I've got a question.
Yeah.
Well, first off, Manas, you said this is for your major thesis. Is that for a master level research project, or can you just tell me about it?
Yeah, so this is actually not my major thesis. My major thesis is on depth estimation and semantic segmentation. So estimating depth from a 2D image, and also estimating a semantic frame on this within the same model. So one model, two tasks. It's a multitask learning. And this was a project which I and Alicia were doing
Yeah, so this is actually for an external company. They basically work in the health and safety services, workplace health and safety. They have no technical background, but they had a good hunch about what could be transformed into an actual product. And we're here to just help them to achieve that. it was just good timing that Manas was there. Yeah,
Okay.
otherwise I would have probably done in a much different way, maybe less accurate way.
Maybe
the
few steps
reason
learning could be handy. Maybe as you didn't have a lot of data, maybe just using some sort of meta transfer learning for few start learning where you give, let's say, 10 examples each, and maybe train on that. That might not bring the better performance, but that would be maybe much quicker, and also you don't need to endnote that many images. And I know the feeling how bad it is to endnote that data, because I'm going through that same thing right now. So
Yeah, so the expectation, I mean, it's always the client expectations would be much higher. And so the end goal is to the end goal of our project is to implement it with the CCTV footage. But however, it's almost extremely difficult to have a CCTV footage of training data. And so for that purpose, we tried to work on GTA images, which is actually available online, and it's a virtual image. It's basically from the GTA game like this, and these are already annotated. It's a 135 gigabytes of images. You would find a million of images. We just took 30,000 sample and tried to work on it. However, this synthetic data wouldn't give us accurate results when it comes to real life scenarios. So yeah, so data is the real asset to a company. I know I don't wonder why Tesla has driven 20 million miles to gather data for its AI system.
So just going back to my question, sorry, I was in the middle of asking something that was a two-part question.
Yeah.
I guess what I was interested in is what sort of project this is in connection to Deakin Uni, because I'm interested in it. I'm doing the Master of AI Professional, and I'm faced with the choice of a research project or a internship. And there's, so just wondering how, like, what is the actual pathway to doing a sort of project like this with Deakin?
Okay, so you're part of SIT, right? I mean, School of IT.
Yeah.
I think, look, Angus, I think the best thing would be maybe just come and have a chat with me and Manas, and because this is probably a long discussion. It's really about what you want to do later on in life. Like, do you want to go towards a PhD? Do you want to go towards industry? So it's not a 1 minute question to answer, but definitely so I run the Deakin Launchpad, and we do projects of pretty much any size. We do these 10, 15K small projects, which are just POCs, which are just, we use them to learn the technology ourselves. But we also do, like large projects above 100 to 100Ks. We handle PhD students. We do a lot of stuff. So I think the simplest way is, just come up. Well, we have a coffee machine, and we can chat about what is best for you, and you can make the decision after that.
Okay, I might email you as well just to talk
Absolutely.
about it.
Yeah.
All right, thanks.
Okay, I think we reached the end. I think this discussion around this actually became quite interesting. Also, thank you, Rita, for actually actively contributing to this discussion. I think that was very interesting. Very happy, but I think we reached the end. Maybe next time we will not do it on a Friday. I don't know what I was thinking when I actually said, let's do it on a Friday. So I think everybody wants to go out and do stuff. But yeah, so guys, thank you very much for coming. And this is the end. We actually had other plans. What we will do a nice wrap up with all the resources, where all the papers are, all the contacts if you want. We'll send it to everybody. And if anyone has any more questions, feel free to take them offline. you can message me directly. My name is Alessio Bonti, and you can find me in Greenwood Park, sadly, pretty much every day of the week. So yes, please come and say hi. So
yeah, thank you, Manas. Thank you, Alessio.
Yep. Thank you. Bye-bye.
Thank you, Mohammed. Rita. Yeah, it's
Yep.
just that it comes up on Mohammed there, so it's counterintuitive. Thank you, Rita. Thank you, everybody, for coming in today. It was really great to make this interactive, because a lot of the times people don't interact, and we really need an out song so that we can put music on. All right, bye bye.
Thank you. Bye-bye.
Thank you. Bye.
But
Bye.